known as Ace. So today I'll be teaching you guys about understanding event-driven architectures and how AsyncAPI is helping build a future for event-driven architectures, like building the future of event-driven architectures. So a little bit about me. I'm actually a very, very small person. And I'm not funny, but I always think I'm funny. So who cares? So I would love to first introduce talk about how I got into open source in the first place. So it is a very, very weird experience. So I got into open source just by fixing a typo. So I saw a typo in one library I was using, this library. So the typo, so I saw it was supposed to be is, but in the documentation it was ha, A-R-A, instead of I-S. So I was like, this guy is not correct. Like, it should be is. So I raised an issue, and the maintainer was like, it's correct. I was like, no, it's not correct. It's supposed to be his. No, it's correct. Guy, trust me, it's not correct. And so it was like, okay, if you think it's not correct, then probably fix it. I was like, wow. So I fixed it. I changed her to his. Guess what? My pull request got merged. It was I was so happy, and I was like, wow, now I can call myself a certified open source contributor. Then from there, I went to contribute into popular open source tools like React, Parcel Bundler, AsyncAPI from Postman, Down4JS, like I'm a maintainer with Down4JS, building cool stuff. So that's a little bit about me. But right now, I'm an open source maintainer and an ambassador program ambassador at AsyncAPI. Basically, we spend Postman money to build stuff. So you can follow me on Twitter, I'm _isbuild. I'm not popular, so I don't have money yet. We have this meet, I saw this meet, so I stole it. I'm not the owner, so it says legend has it that you can only interact with web services using REST APIs. So the same legend also has it that HTTP is the only way of communication on the interweb. And I am here to buzz this meet by introducing you guys to event-driven architecture and a community whose mission is to build the future of event-driven architecture. So an event is an action or occurrence recognized by software, often originating asynchronously from external environment that may be handled by software. I'm not that brilliant to come up with something like this, so I stole it. So I came up with a diagram that says, first of all, this is an illustration of how an event works. So step one, a user interacts with a page, probably a checkout button, which is an event, technically. So an event occurs, you can say in step two. Then step three, a piece of code runs in your response to charge your card. So you're trying to check out. Then step four, the page appearance is updated or modified in some ways. Probably telling you, oh, you don't have insufficient account balance, so you can make this purchase. Probably my card. So what is an event-driven architecture? So event-driven architecture is a software architecture and a model for application design in which the coupled application can asynchronously publish and subscribe to events via event brokers. Modern message-oriented middlewares, so such as Kafka. I don't know if anyone knows Kafka, Apache Kafka, Rabbit MKQ. So more details. So an event-driven architecture basically enables your application to act based on events as they occur. This ensures that when an event occurs, information about that event is sent to all the systems and people that needs it. It's a very, very simple concept, but this event have quite the journey. They do a lot of stuff, very, very awesome. So they need to efficiently move through multitude of applications, written in many different languages, using different APIs, leveraging different protocols, and arriving at many endpoints, such as applications, analytics engine, and user interfaces. So now, you guys are, if you're not familiar with event-driven architectures, you can be wondering, oh, so how does this work? How can I use it? I'm comfortable with using RESTful APIs. Okay. So event-driven architecture is made up of three major components called the event producer, the event manager, and the event consumers. So I'm going to like explain it one by one. So event producers detect or senses an event. So like when you click on a checkout button, so they're actually like producing an event. So event producers detect or senses an event and represent the event as a message. It does not know and care about who is consuming the event, so who the consumer of the event is, or what the outcome of the event is. Like the producer doesn't care. It just produces events. So event managers act as middlewares and are responsible for asynchronously filtering, processing, and routing received events. I basically call them the event transporters. So, some examples of an event manager includes the Apache Kafka, RabbitMQ, Amazon SQS, IBM MQ, Red Hat MQ, and etc. That there are tons of them. Here, the consumers, the lazy ones. So the event consumer is the logical complement of the event producer. An event consumer accepts event objects from entities in an event processing network, that's the event managers, and process them. They do whatever it is they want to do with the events. Probably tell you account balance is insufficient. So how does the event manager knows which consumer a message belongs to? So since the event producer doesn't care what the message looks like or who is getting the message, all they do is just publish the message, the producers. So how does the managers know who should receive this message? Like, I don't know, this guy just give me messages, doesn't tell me what the message does. So how do I know who tunes the message? So once the event producer has produced the message and sent it to the event manager, the manager has to decide who gets the message. Thanks to the publish and subscribe system that follows the typical event-driven architectures, from the, like, a lot of us know them as pub and sub. So from the pub and sub perspective, the producer acts as a publisher. That's the producer is the publisher in this concept, and the consumer acts as a subscriber. Then the manager may now contain multiple message brokers that transfers events and push them out to all interested consumers. So let me just break that down. So once the publisher is producing message, so the publisher can just send message to the message managers. He has to know, like, the manager has to know, oh, this message you're sending, what channel are you sending to? You can't just give me tons of messages and say, hey, here you go. I don't know what to do with the message. So in order to make it very, very easy and accessible, the manager has to, like, let me just call them rooms. So the manager has different rooms. So now the publisher can say, oh, I have this event. I want to publish this event to room 1. Or say, oh, this event I'm like publishing, or this message I'm sending to you belongs to room 2. Then the manager knows, oh, this message is for room 1, this is for room 2, room 3, and so on, and so, I don't know, whatever. Then the consumer now comes in and say, oh, I need this message. I need to, like, pay this guy. He doesn't have money in his account. So what room am I going? What room am I looking for? That's what room am I subscribing to? What channel am I subscribing to? Then say, oh, okay, I think for an insufficient account, just go to room 1. That's where Azeez definitely belongs to. So go to room 1 and, like, look out for message related to insufficient balance. It doesn't work like that in the real world anyway. So I came up with a very simple diagram, just like show how it works. So you can see we have 3 producers. We have producer 1, we have producer 2, we have producer 3. Producer 1 publishes an event A, 2 publishes B, and 3 publishes C. Now we have the event manager, aka Kafka, like, for example now, AsyncAPI cluster. You can see they have different brokers. So I probably, like, just publish it to whatever broker they need to publish to. And now you can see these consumers. We have consumer A, consumer 1, consumer 2, and consumer 3. Consumer 1 is actually subscribed to A, event A, so to whatever channel this belongs to. Consumer 2 does the same thing. So a consumer can actually subscribe to more than one channel. As a consumer, I can subscribe to multiple channels. So, like, oh, I want message from this channel, I want message from this channel, I want message from whatever channel I need. So the same thing with event consumer 3, also, like, subscribe to 2 channels, event B and event C. So I came up with a real life use case of event-driven architecture. So let's take a simple pizza ordering scenario in a real world perspective. Like all of us like, love, who doesn't love pizza? Come on, apart from pepperoni. So the first step is user profile, where customer can place a pizza order. The second step, a food delivery service, just schedules delivery time and assign delivery man to orders. Restaurant partner service takes a pizza order and notifies when it's ready. This is like a microservice. Different microservices like working together. So I tried to come up with a visual representation of what just happened, but I didn't do it very well. Even me, I don't understand what I just drew here. So I will try to explain it. So anyway, you're seeing a green arrow, it's actually publishing events. So anyway, you're seeing a red arrow is probably just subscribing to an event, listening to an event. So the user profile service, the food delivery service publishes an event to user service. So explaining the diagram I just showed you guys. So the first step is the user places an order for a pizza via the user profile service, a mobile app UI. The service captures such data as user's name, current location, contact information, etc., and publishes the pizza order event. The food delivery service like Uber Eats subscribes to the pizza order event that was published by the user. So it reacts to it by publishing the take pizza order event. Step 3, the restaurant partner service, which is another service on its own, which is subscribed to take pizza order. So that's like the pizza order, the food delivery services is consuming from the user. So the restaurant partner service, which is subscribed to the take pizza order event, fulfills the order and publishes the pizza order ready event. Then we have the food delivery service also. So the food delivery service sends allocates the nearest delivery man and schedules a delivery time event, respectively. It can now monitor the location of the order and provide estimated time of arrival notification for the user. These are different services that works that are hosted, it's just a microservice, hosted on different platforms, and they communicate together. So I don't know if you've actually used the Domino's Pizza, the app. So this is how it's being handled. I won't tell you gave me that information. Common use case of event-driven architecture. So I won't go into depth. So we have the Internet of Things, we have online shopping, we have healthcare, we have online banking, etc. So why event-driven architectures instead of HTTP request? Which is a very, very good one, I think. So why event-driven architectures, not HTTP request? I can have different microservices. I can just use HTTP to communicate with them. Who cares? I just want to use that anyways. So in a typical request response scenario, the client waits for the server to respond. It blocks all its activity. You can't do anything until you get a response from the server. That's what HTTP is. That's crazy. I don't like it. It blocks all the activities until it receives a response or the timeout expires. So you can't do anything. You just have to wait. You don't have any choice. I don't care who you are. Just wait to respond. I don't care how waiting what you is. Who cares anyways? If we take this behavior and put it in a microservice architecture using chain calls across different systems, we can easily end up with what I call microservices. Hell, I don't know. I'm not a backend guy, but I'm doing backend mostly. So it doesn't make sense. Microservices looks like it's weird. Everything starts with one service call. Let's call it service A. But then service A needs to call service B, and then the phone goes on. The problem with this behavior is that if a service has resources blocked, e.g., a thread is hanging, timeouts are now exponential. If you allow a 500 milliseconds timeout per service, and there are 5 services called in the chain, then the first service would need to have a 2,500 milliseconds timeout, that's 5 seconds timeout, whereas the last service would need to have a 500 milliseconds timeout, which doesn't look cool at all. Oh, am I going back? So why this sudden shift? Why should we use event-driven architecture? Why don't we just stick with HTTP requests and stuff like that? So I'm not going to go in depth. Then like just explain the first part. So in contrast, the shift of event-driven architecture is primarily driven by speed and responsiveness. You can, like, it is very, very fast, like fast than HTTP. This isn't an example of internet users wanting data on request. You can see how aggressive users are on mobile app. Like they don't like downtime. They don't like when your system is slow. Like I'm trying to like pay for something and stuff like wait to do other stuff. Doesn't make sense. So it's an entirely different paradigm where increasingly people are looking for a proactive, real-time, and individually customized experience. In other words, don't wait for me to ask for something. Inform me when something that interests me changes. Like when I have, so I know, how many of you here have used Socket.io? Like WebSocket, yeah, WebSocket. So you can say how you use Socket.io to like build your chat rooms. You can use it to be chat applications. So you can say, you send messages and once it is ready, identify like as a user, oh, you have a new message. So I don't have to like wait, like send message. I'm like, oh, I have to wait till the message gets sent. Oh, yeah, I can't do anything else until that message get delivered. Like, how do you think that would make sense? Like, imagine I have to like message this guy. I'm like, hey, bro, what's up? And I have to wait until the message sends before I can go back to do other stuff to message somebody else. How will you feel? Come on, like there won't be WhatsApp, I guess. So, advantages of event-driven architectures. So, loose coupling, like if you are familiar with microservices, you will know much about this, but I don't have much time to like start explaining. Resilience and broadcasting. If you use Socket.io before, you would know, you'd be familiar with the broadcast, like the broadcasting feature on Socket.io. How you can send messages to multiple rooms, like or to multiple users in the room, I guess. So, introducing the AsyncAPI. So, what is the AsyncAPI? Why am I even here to like say AsyncAPI? I'm very sure nobody knows what AsyncAPI is in this room. So, AsyncAPI is an initiative whose goal is to be the future of event-driven architectures. AsyncAPI builds open source tools to easily build and maintain your event-driven architecture, all powered by the AsyncAPI specification. We have a specification, isn't that cool? The industry standard for defining asynchronous APIs. Why AsyncAPI? The developers of AsyncAPI identified the lack of tooling in message-driven space. Like, I'm not sure, I don't know, I think, I heard somebody saying something like this exists in AWS, like, but I'm not sure how true that is. So, like, imagine there is, you know how you guys use OpenAPI, Swagger, to like document your REST APIs? Now, something like it doesn't exist for event-driven architectures. Like imagine if you have different microservices in a company and you are trying to like onboard a new team, like a new member in your team, and you have to like start sitting the guy down and like explain how this microservice communicates with these. Unlike REST API, you could just give the guy the Swagger link or something, just go through it, find your way, and make your first pull request or something. So AsyncAPI is just the open API of event-driven architectures. So the developers of AsyncAPI identified the lack of tooling in the message-driven space and were presented with a conversely abundant set of tools for HTTP APIs, decided that there was a missing piece of standardization in documentation specification. REST APIs have OpenAPI, messaging has AsyncAPI. So message-driven APIs are very, very, very different. However, they need their own solution that covers the caveats and considerations to message-driven architectures. For these APIs, there is AsyncAPI, which does functionally the same thing as OpenAPI, but with a message-driven focus. Adopting AsyncAPI is a no-brainer for message-driven APIs, like for real. So we have our own specification, the way OpenAPI has its own specification. So its purpose, like you can use it for event-driven microservices, Internet of Things, streaming APIs like Netflix, and actually pretty much any system based on messages. So we support different protocols. We have AMQP, Kafka, WebSockets, you can see. So if you have a platform built using Socket.io, here you can do WebSockets. We have HTTP. Like we have like, I'm not supposed to be sharing this. It's supposed to be like low-key. We're actually planning to like chase OpenAPI out of the market. So I'm sorry, guys. OpenAPI will be gone soon. You guys using the SYNC-API. Any protocol, like any protocol, just mention it. So we have the specification. So a file per application. So you can have, let's say you have the microservices, you have the, I don't know, transactions, you have different microservices. So every microservice has its own file, and a SYNC-API file. We have different, like the way OpenAPI does, or the we also have the info schema, the server schema, the channel schema, and the component schema. So we are trying to like replace almost everything. So we are replacing WebSocket. So that's what GLI is. So we have the SYNC-API CLI. We also have, I don't have it here. We also have like a visualization tool at the SYNC-API where you can just visualize how your microservices or how your architecture are like connected together. And you can see like a stream of which one is publishing and which one is consuming. So we also have, I don't have it here also. We also have, how many of you how many here are familiar with Scratch? Like how many people started coding with Scratch? Yeah. So we have a Scratch inspired project where you can just drag and drop different blocks to like generate or document API specifications for message-driven events. Like it's cool. Just like drag, info, then what do I need? No single line of code. So we also have a chat bot. So you might be too tired and you don't want to like just want to chat. You have a chat bot you can talk to, and based on your conversation, the chat bot automatically generates a specification for you. How cool that's fucking cool. I actually worked on that anyways. So the initiative, we have specifications, we have tools, I've shown these. Let's talk about this. So we are getting a lot of recognition lately just because like a lot of companies are like adopting event-driven architectures for real. Oh, the growth. Now I've spoken about this. So Elegbede is actually a developer or an advocate at Postman. I actually brought him here to Nigeria. I said, "Oh, come on, we spend your money. Why don't you come here? Like, come to this booth, like, come to this OSCAFEST." So, Postman partnership. I told you they basically pay for everything. Like, take our money. We have more than enough. Just spend it. So, we also joined the Linux Foundation last year, I guess. So, we have a very, very big vision. So, I said it earlier. We're trying to like kick OpenAPI out of the market for real. I don't mind going the extreme mile to do that. So the vision is to make AsyncAPI becomes the #1 API specification for defining and developing APIs, no matter what kind of API you're building. So we are like, some amazing companies are actually like using us in production right now. We have Salesforce, we have Adidas, we have Slack, we have SAP, like you can see, like, isn't it cool? We have Slack, oh guys. Slack is using us. We spend Solars, we spend Slack's money, we spend a lot, but we spend Postman money mostly. So you can join us because AsyncAPI is actually, the initiative is open source. So everything we do is open source. We have a very, very amazing community around AsyncAPI. So we're also looking for contributors. So if you are looking forward to like make your first contribution, you should come join the SYNC-API, front end, back end, whatever your stack is. We are glad to like help you on board. Like we're not that kind of open source project where you say, "Hi, I'm just in this issue," and they hear you like Air Pro Max till like next 6 months before the maintainer like reach out to you. No, we don't do that. You say you're interested in this issue, you'll see somebody to help you instantly. I'm part of those people that reach out to people that need help. I don't like it doesn't we even do video calls with contributors. So we host public meetings. We are like our transparency is like better than 1%. So the initiative, you can join us probably here. We have a Twitter handle. We're on Slack. So we basically use Slack to like communicate. We're on LinkedIn and GitHub to find all of our repositories. Everything is public, no private. And the website is www.asyncapi.com. And that's pretty much everything, guys. If you have any question about event-driven architectures, you should probably see me later. because I have to be honest. So if you're using Postman, if you use Postman day in the house and you have questions about Postman, you probably say Alemi is a big boy at Postman, so it would answer all your questions related to Postman. Because he's like the only white person here, the most whitish person here, so he's unique. Go look for him. All right, thank you guys. That's everything.